Myself, K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. I am going to discuss the course, the dynamics of machinery. In that, we are going to discuss today importance of gyroscope and gyroscopic effect, and application of gyroscopic effect, such as shift, such as aircraft, ship, aeroplane, and two-wheeler and also four-wheelers. Let us discuss what is gyroscopic effect, when it will be taking place, how the gyroscopic effect takes place on the body. Generally, people know gyroscopic effect. Suppose if you are taking the direction, if you are traveling in a curved path, when you are traveling a curved path, the force we have when we are traveling in a curved path on a two-wheeler, what will happen? There is a force which acts towards the radius. That force is called as centripetal force. When the force acts outside the radius, then it is called as centrifugal force. This centripetal force acts towards the direction of the radius at the center, towards the center. This centrifugal force is called as active force. Whereas this centrifugal force is called as reactive force. So here we are studying the gyroscopic effect to understand the principle of gyroscopic effect. We are considering there is a wheel. This is the wheel. At one end it is fixed. It is fixed or hanged by the rope. Another end is tied with a wheel. It is nothing but a cycle wheel. So when the wheel doesn't have any rotation or any motion, if you hang it, the wheel falls down due to gravity. But at the same time, if you give some angular motion or angular rotation to this wheel and hang it another end to a thread or a rope, then leave it. It rotates about this vertical axis. That motion is called precessional motion. That motion is called as precessional motion. That is called precessional motion. Now, by using the right hand rules, how can we know the vector of angular momentum? So in this case, we can see here, if we keep our finger if you fold our fingers, take your right hand, fold your fingers in the direction of the rotation of the wheel, then this thumb indicates, suppose these are the fingers I have folded in the direction of rotation, then this thumb indicates the vector, the direction of the angular momentum. The direction of angular momentum represents this vector, this thumb direction. So we will use here similarly in the case of couple also, how the couple takes place. If you have to fold the fingers in the direction of the rotation, then this thumb indicates the direction of the particular angular momentum vector, or couple means direction of the couple, and it is a precision means the direction of precision. Alright. So thus we can find out the directions of angular momentum. and also direction of couple and also direction of precision. We can know it. Now here, very important, this gyroscopic couple or gyroscopic torque equal to I times omega into omega p. This I is mass moment of inertia. Mass moment of inertia. What is this omega? This omega means angular velocity. That is in radians per second. This omega p means precisional angular velocity. That is omega p. So there are three types of axes. Suppose we can understand better, more. This is a gyroscopic. We considered here is the gimbal. So we can understand the principle of gyroscopic effect on a gimbal. So here the gimbal is attached without applying any motion. Then it is falling down. That means due to gravity. Now in the next slide you can understand better. Before going to understand about these examples, let us discuss the principles more better. How the gyroscopic effect takes place in different axes. This is axis of spin. And it is the axis of precision. There is the third axis will be there. The third axis, this third axis indicates the axis of couple, gyro couple. So this axis of spin, precision and couple, better to understand, start understanding about the plane of spin, plane of precision and plane of couple. Then we can understand the effect of gyroscope. Let us draw the planes. To make you to understand better, no need to by heart about the gyroscopic effect or formula. As I told you, this is the axis of spin. This is the axis of spin. This plane is called a plane of the spin. Now, as I told you, this is a vertical axis. This vertical axis, as I told you, is the axis of precision. This axis of precision means precision takes place on your horizontal plane. This plane is the axis of precision. Axis of precision. Plane of precision. Already axis of plane of precision. There is another plane which acts normal to both plane of spin and plane of precision. What is that? This is the plane. You understand? That plane is called plane of gyro couple. Plane of gyro couple. So thus we can understand, suppose the axis of spin is in this direction and axis of plane of precision is perpendicular to the plane of spin, and plane of couple is normal to plane of spin and also plane of precision. On that plane, this gyroscopic effect takes place. That what is the axis? This is the axis. What is the plane? That plane is normal to both spin and also precision. But here gyroscopic effect means the reactive force gives the effect of the reactive force is the gyroscopic effect, not the effect of active force. So gyroscopic effect means reactive force which gives able to balance the system. As we are moving a two-wheeler in a curved manner, if you turn along the vehicle, you tilt down, you fell down, tilt it. What to do? You have to, even though it is tilting, you have to turn, you have to give vertical in this direction, centrifugal direction, you have to bend to balance the tilting of the vehicle. So when you tilt, the active force acts. So if you also able to tilt in this direction, what will happen? There is a falling down takes place, vehicle falls down. So further to balance that centripetal force which is acting towards the radius, we have to balance, we have to give to equal and opposite direction to the centripetal force, that is called centrifugal force. Then the person has to sit straight. So automatically it will balance. You are acting the force opposite to the direction of the centripetal force. That centrifugal force is called reactive gyroscopic, reactive gyrocouple. That is known as gyroscopic effect. Now, in order to understand the principle of gyrocouple or gyroscopic effect, scientists has designed a toy. That toy is called a gimbal. So here the person is, without giving any motion to the gimbal, he attached on support. Then what happened? Then immediately is falling down. It is like in Telugu it is called a bongaram. The person who rotates, it will be like that. The person who will, if you see, there is a circular disc attached here with a matchstick. You keep it with a mud also, you can make it as a disc, and through that mud at the center you pass through a matchstick, burnt a small, at the edge burnt one. Then with the mud you attach this, you start rotating. This toy is called in Telugu is bongaram. It completely rotates. It will not fall down. Without giving rotation, if you try to make it stand this bongaram will fall down. How the gimbal is falling down. Now this motion makes to balance completely. In next slide you can see how the gimbal rotates and also it balances. Now you can see in slides here, in before slide, without giving motion to the disc, what happened? It fell down. Now after giving motion to the disc and he attached at one end, it started rotating. Now you may ask question, generally when the direction of rotation is in this direction, gimbal, now what is the direction of the precisional motion? What is the direction of precision? Is this in forward direction in this or in reverse direction? So you can understand here that gimbal is given motion in this direction. The precisional motion takes place. How the precisional motion taking place? With the vertical axis. This is the vertical axis. This is the axis of precision. Horizontal, whatever rotating. Axis of precision. Now the same, instead of support, in this figure, he attached on a finger, forefinger, how it is rotating. How it is able to rotate. Yes. Here you can see about vertical axis. So this represents the gyroscopic principle. Now this is the updated version of this called preparing the burger or one of the food item. So if you give direction of motion, how it is rotating is the gimbal. The gimbal is used for frying what is called as a burger. So we can use the gimbal for frying purpose also. Now coming to the picture of next case study. we will study the aircrafts. So it is in this figure, the aircraft is taking off, and in this figure it is propeller craft is maneuvering about vertical axis, is rotating about vertical axis, and in this direction the aircraft from horizontal to vertical it is taking off. How the effect of gyroscopic takes place, we will study. Now this is another example for gyroscopic effect, how it balances the vehicle or aircraft. Alright, so we are going to study systematically now with different examples how the gyroscopic effect takes place. Let us begin by taking different problems. Let us start gyroscopic effect on airplane. Now it is a plane having a propeller the wings. Okay, here the plane of rotation of the propeller is clockwise direction when we are viewing from tail end. Viewing from tail end, and it is taking left turn with a certain radius, taking left turn, with certain radius. Now what is the gyroscopic effect on this plane? What is the gyroscopic effect on this plane? How do we have to do it? How to start? When we are viewing from this, how to represent the vector, the direction? In order to understand this, to attempt this problem, we have to understand the vector notation of angular velocity. Suppose there is a circular disc attached to a shaft. It is in this direction. So if you keep the direction of rotation, it is in clockwise direction. If you keep in direct clockwise direction, if you fold the fingers in the direction of rotation of your disc, this thumb indicates the direction of the angular velocity. So this is the direction. What is the magnitude? The magnitude of the angular velocity represents the length of the vector. Alright. Similarly, now coming to this point of this aeroplane case, the propeller is rotating the direction of how much velocity, taking left turn. When you are viewing from rear end, this is left side and it is right side. It is left side or left hand side, it is right hand side. Now the propeller is rotating in a clockwise direction when we are viewing from the rear end or tail end. So the direction of the rotation of the vector is in this direction. It is rotating some n rpm. That n rpm should be converted into magnitude, that is omega n, omega equal to 2 pi n by 60. This value comes omega. We make it the length of the vector is the magnitude of the propeller or speed of the propeller. Then it is taking a left turn. When you are viewing from the rear end, it is taking left turn is this direction. Taking a left turn. Now join this. Then this is the direction of active gyroscopic effect. Active gyroscopic effect is in this direction. What is the direction of active gyroscopic effect? You keep your thumb in the direction of the vector. Which vector? This is the vector now. Now this arrow, your forefinger, this fingers indicates the active effect of active gyroscopic, active force. This is the active force. What about reactive gyroscope? The reaction will be opposite to the direction of the vector, active vector. Now you keep the fingers downward direction, keep the thumb in downward direction. The folding fingers represents reactive gyroscopic effect. Now from this is reactive gyroscopic effect. This reactive gyroscopic effect is called as gyroscopic effect. Now this is the direction. Now what is happening in reactive gyroscopic effect? What is reactive gyroscopic effect? This end is called, this side is the nose end and this end is the tail end. What will happen now on the plane? The nose will rise and tail will go down. Nose will be raised and the tail end will be goes down, will be gone down, or will go, the tail end goes down. Now the plane, when it is taking a left turn, if you have observed, if it is taking a left turn, not during the takeoff, nose will go up, tail will go down. But when already took off, okay, if you want to take a left turn, the nose has to be raised and tail has to be dipped. So then the plane becomes in this direction. Okay, it has to raise, tail goes down. That is the condition in this, the effect of gyroscopic couple in this conditions, in these conditions. What are the conditions are? When viewing from rear end, the propeller is rotating clockwise direction and the plane is taking left turn. Now, second case, we are going to study case 2. In this, conditions are what are the conditions? Number 1, when viewing from rear end, or tail end, the propeller is rotating. Propeller rotates in counterclockwise direction, and or you can consider only clockwise direction, but it is taking now, plane is taking a right turn. Then what is gyroscopic effect on the plane? How to start this? Let us begin. I am considering aeroplane, a simple model. When we are viewing from Thailand, now the propeller is rotating clockwise direction, but it is taking which turn? Right hand side turning. Now you fold your fingers in a clockwise rotation of the propeller. This thumb represents the direction of the angular velocity or vector. Now it is taking, the plane is taking right turn. The right side means this is the right side direction, taking right turn. Yes. Now join, suppose this OA. Now new vector OA dash after taking right turn. Join A to A dash. A to A dash, keep the finger, thumb, your main finger in the direction of A to A dash. This folded finger denotes, represents the effect of active gyroscopic. And now what is the reaction? Make it a direction A dash to A vector. Then what happens? If you keep the thumb in the direction A dash to A, this folded fingers represents the reactive gyroscopic effect. This is the reactive gyroscopic effect is called as a gyroscopic effect. Now what will happen? The tail rises and nose goes down. The tail will be raised and nose goes down, the propeller end, during taking right turn. It has to be taken place. If it doesn't take place, what will happen? Suppose you are traveling in a two-wheeler, right side direction or this curve path. You have to balance. Others, if you travel in this direction, topsy-turvy takes place. In order to balance the two-wheeler, you got to know it automatically. As a God designed your body, you know it how to balance at that moment. Proportionate to your vehicle, what you will do, you will balance it little bit. You try to turn towards opposite to the direction of rotation. Thus, vehicle will be balanced. Your turning gives the centrifugal force. That balances the centripetal force. So this is the effect of gyroscopic effect or gyroscopic couple when the plane takes place right turn, provided the rotation of the direction of rotation of the propeller is clockwise and it is taking right turn. Now next case 3. In this case, we are going to study plane is rotating, aeroplane is taking left turn and propeller is rotating in counterclockwise direction. When viewing from rear end or tail end. So how to start this? We have to start again. You are viewing now it is counterclockwise direction. Counterclockwise, and it is taking left turn. This is LHS side and it is RHS side. Now keep your fingers, as I told you, in the direction of the rotation of the propeller. It is in counterclockwise direction. Then what will happen? When you are viewing from the rear end, it is in counterclockwise, viewing. Now the direction of rotation, the vector, angular velocity vector will be in this direction. That is OA. It is taking left turn. Now it is taking the left turn from this viewing. Now when you are viewing from this left turn, which is one, left direction or right direction? This is the left turn. Viewing from left turn. A dash. A to A dash. The direction of the vector. Now what is the effect? Keep your thumb in the direction of A to A dash. This fingers folding direction indicates the active gyroscopic effect. What about reactive gyroscopic effect? It will be in opposite direction to the reactive gyroscopic effect. Now, in the reactive gyroscopic effect, what is happening? Reactive gyroscopic effect, tail goes down and nose rise up. So that is the effect of reactive gyroscopic effect on the plane. Now let us solve some other problems. How to calculate the gyroscopic couple? In this aircraft case, there is only one formula to understand the effect of in order to calculate the gyroscopic torque. That gyroscopic torque GT equal to I times omega P. This I is mass moment of inertia. It is not area moment of inertia. Why shouldn't we use area moment of inertia here? Why only this mass moment of inertia? Because we are dealing with the solid bodies. When we are dealing with solid bodies, we have to use mass moment of inertia, not area moment of inertia. When we are studying, let us discuss the concept of when to use this mass moment of inertia and area moment of inertia. There are two types of moment of inertias. Number one, based on area or geometry related. This is based on volume, that is mass moment of inertia. This area moment of inertia related to particularly when you are talking about different rectangular planes, squares, circular planes, different. Yes, there is a plane geometry. Is for solid geometry, solids. So we have to use mass moment of inertia. Here, the gyroscope, the mass moment of inertia, why we have used? Because we are dealing with solid bodies. Okay, that is a propeller. Propeller is not a plane. For that, we are using this mass moment of inertia. The mass moment of inertia unit is kg meter square or kg centimeter square or kg millimeter square. Then what is omega? Next parameter, what is omega? Omega is angular velocity. Angular velocity. This angular velocity unit is radians per second. Next, omega p is precisional angular motion. Precisional angular velocity. precessional angular velocity. Now, let us start solving the problem. On simple problem is that disk, if you consider circular disk, okay, there is a circular disk. It is fixed at one end and it is fixed, or it is fixed at the one end of the shaft. Another end of the shaft is fixed. It is having certain angular velocity. That angular velocity omega equal to 10 radians per second. The mass moment of inertia I equal to 20 kg meter square, and omega p also given. This is the direct substitution formula. We are given certain value, that is some 5 radians per second. This omega p, okay, if you know all the formula substitution, what is the gyroscopic effect? What is the gyroscopic effect or gyroscopic torque? It is very simple. Put the formula and get the answer, because everything was given directly. So the gyroscopic torque Cc, or gyroscopic couple Cc equal to I times omega p. Now I equal to 20 kg meter square, 10 into 5. So if we know these values directly, we can get it. This is 200 times 5, that is 1000 units. Gyroscopic couple. Thus, we will calculate the gyroscopic effect, gyroscopic torque on circular disc. Now, I am going to introduce about 4-wheeler and 2-wheelers, and one more application is that is a ship. So, let us start the ship case. So, in the case of the ship case, that is, we are going to study gyroscopic effect on ship, or it is also known as sea vessel. If you consider the ship, this is the top view of the ship. This is the front end. This is the front and it is rear. And it is left hand side and right hand side. There are different names are there. Starboard, okay, fore end. Okay, different names are there, LH side, left hand side and right hand side. Now here we are going to discuss the effect of gyroscope more in the next coming class, coming lectures. But here I am going to introduce how the effect of gyroscope takes place in different directions. So when the ship is when it is moving up and down, this up and down motion, that is called pitching. Okay, if you consider the ship, this is up and down motion is the pitching. That is known as pitching. During pitching, these oscillations will be taking place. Okay, based on if it is, okay, it causes oscillations. When these oscillations taking place, we have to study the time period or frequency of oscillations. Next, During rolling will be there. This is called rolling. Okay, the motion. The motion about longitudinal axis is called rolling. About this longitudinal axis. This is longitudinal axis. The normal to the longitudinal axis is known as a transverse axis. Transverse axis. So when the motion is about the transverse axis, this is the transverse, then it is called pitching. When the motion is about longitudinal axis, then it is called rolling. And when the ship is taking left side direction, what is the gyroscopic effect? When the ship is taking right side direction, provided when we are viewing from rear end, of the ship, then what is effect to the fore end or front end and rear end? And what will happen? What is the gyroscopic effect when the ship, provided we are going to give the propeller, rotation of the propeller will be given here. Is it clockwise rotation or anti-clockwise rotation? Based on the rotation and the direct rotation towards or traveling or passing the ship, moving towards left side direction or right side direction. In the case of the ship, 4 cases will be there, more than 4 cases. When the ship is taking left turn, when the ship is taking left turn, provided here conditions, we are considering under this case when we are viewing from rear end, propeller is rotating, our engine is rotates, engine is rotating, engine direction is clockwise direction. Next, engine direction is clockwise. Next, when the ship is taking right side direction RHS, then what is the effect? Next, case 2. What is the case 2? Viewing from rear end, our vision is viewing from rear end. Now engine rotation, engine is rotating counterclockwise direction. What are the cases again? Under those cases, the ship turns left hand direction, and again second case is right hand direction. This is for when engine is rotating. There are 4 cases for when engine takes turn left side direction, right side. And one more thing, that is for during taking left turn or right turn. Now the point is that we are considering only rear direction, so that we can easily understand all cases. After that, after thorough understanding these cases, we can interpret more when we are viewing from front end, then how the effect of gyroscope takes place in the same mentioned during left turn and right turn of the ship. Now, case 3, the case 3 is that, suppose what is the effect during rolling? On the rolling motion, during rolling, what is the gyroscopic effect? And case 4, during pitching, what is the gyroscopic effect? So, under the case study, under the study of ship, or under the application of ship or sea vessel, What is the gyroscopic effect? These are the 4 different studies are there. This is for ship. So far we covered or we understood the effect of gyroscopic. What is gyroscopic effect? And what is the principle of gyroscopic effect? And what is the how to draw the vector diagram by using right hand screw rule. Next, in relation to the application of gyroscope, we have studied theoretically what is the gyroscopic effect on aircraft or aeroplane or jet plane also. And case 2 is second application is effect of gyroscopic effect on ship or sea vessel. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.